what we have today is, I think, really a number of really great updates for the ANGSA team, tied to meetings, lessons learned, sample processing. So why don't we go ahead and start with some of these updates shortly. Francis, do you have anything you would like to say?
I'm going to let Ryan and Juliana give a curation update, but I think that happens later in the agenda, right?
No, it happens right now.
All right, perfect. So Ryan and Juliana, take it away.
All right. Let's see if I can share my screen. Oh, hey, Chip, can I share my screen? Because I have some cool slides to show.
Yep, let me. I'm not sure I can do that. Ingrid, are you there?
I'm here.
Could
Okay.
you go ahead and have Ryan be able to share the screen?
Sure. Ryan, you logged in as? Are you logged in under your full name?
I have no idea. Let's see. Participant
okay.
R.A. Ziegel.
Okay. I have to assign you as a co-host.
Oh, that's a sign of the apocalypse, I think.
See if you can share now.
All right. Yes. Okay.
Okay.
I'll just share my screen. All right, can everybody see that? Okay, so it's been a while since we've done this, and a little bit of this might be a repeat, but just so that we're all on the same page, thought I'd get us caught up. So 73002, the third pass dissection is complete. You can see the picture on the left. That was right after they removed the plates. You can see the BAC and the SBAC sticking up as prominent positive features. And then the image on the right is after they've done the D-rind and before they've started the actual dissection. And then here you can see, you know, the dissection in the middle with the second biggest class, the SBAC, sticking out. And so this was all done back at the by the end of April, very beginning of May, and it's been completed. So as part of this process, 8 greater than 1 centimeter class were separated out. And so, I'm sorry, here's the final view of it from the top down, looking at, this is the current surface of it. You can see the darker space weathered material on the right, and then on the left you can see, and the lower down in the core, you can see the sort of more uniform gray, light gray material, and you can see that the darker material is asymmetric across the core. And that was important because some of the allocations we did from this were non-standard, not just the half centimeter dissections across it. As part of this third dissection pass, they separated out 8 of the class that were greater than 1 centimeter, which is 8 more. We only had 2 up to this point in the first 2 passes, but now we have 10 greater than 1 centimeter class. And this is the biggest class in there. This is the BAC, and it was actually scanned twice with our 180 kV source on the left and 225 kV source on the right, because it was right in the middle in terms of the size that's needed in order to properly penetrate. Turns out the 180 does a better job, and it is some sort of regolith. It is a regolith breccia with Schlieren in it, and I just thought it was interesting. The one that's probably most interesting for everyone in terms of the greater than 1 centimeter class that were separated out is this one, which is the largest and only greater than 1 centimeter salt class that was separated out. And so this is more like 9.5 millimeters. So we rounded it up to 1 centimeter and separated it out. Remember, this pass, unlike the first 2 passes, weren't sieved. And so we don't have dozens or hundreds really of 1 to 2 and 2 to 4 separated out, class millimeter size particles separated out. And so this is a really nice basalt clast, and I don't remember the weight of this, but it's over 100 milligrams. So this is a nice, this is the biggest basalt clast we have.
Hey, Ryan.
In addition to the normal processing, we did a couple specialty allocations for folks. Jamie, Elsa, and her group wanted to, look at organics, and they particularly wanted to look at the dark material that was space weathered and the more space weathered, and then the lighter material. Because it was asymmetric across the core, and because we didn't want to use up an entire interval for these 2 gram allocations, we spread them across three intervals, and we also took them from only one side of the core. And so Jamie got a sample from up here in the 5th, 6th, 7th intervals, and then from the bottom towards me, or towards the bottom of the screen for sample 3 from intervals 19, 20, 21. And I think that worked out well and preserved the precision of those intervals for future work. We also, on the extreme right, I think you can see, we tried to do sub-interval dissection for keys to exist, so that his group could look at the very top 1 centimeter of the core and see if they could see any fine scale evidence of cosmic ray stuff, to use the technical term. We were using 3, the spatulas that we use to dissect the core are about 2.5 to 3 millimeters wide. So dissecting any finer than that is very difficult. The poorly consolidated nature of this core also didn't lend itself to that, but we're fairly confident we were able to get 4 consecutive sub-dissections from 0 to 3 millimeters, and then from 2.5 to 5.5 millimeters, and then from 5 to 7.5 millimeters or 8, and then from 10 down to about 7. So there's some overlap between them because it was unavoidable, but we got those to keys, and hopefully it'll tell him something informative. So that was pass 3. In addition to that, pass 2 allocations were complete, and before anyone's head explodes, there are going to be caveats to that. You can see Andrea in the top right there preparing 120-ish individual subsamples to go out to the different groups. And the main picture there, you can see Jeremy helping her after he agreed to help without asking her what she needed help with. So Jeremy learned an important lesson there. Confirm what you're being asked to help. And that is them sorting them out to make sure everything went out. Now, I know there are people who are still waiting on samples. Alex and Richard, you both need samples, and we need to straighten out the loan agreements with that. And I've been waiting to get information back from our legal department, and I think I have that now. And so after the meeting, we can talk in a little more detail about that. And Darby, I know you're still waiting on glass beads, but we haven't been able to have visitors. I do know that you were going to work with Chip and the group and his group that had separated out, had sieved material, and therefore it was easier to separate out glass beads. So I'm not sure if you got what you need, but we are able to have visitors now. So if there is a need to come in and hand pick through bulk unsieved regolith, less than 1 millimeter regolith, we should put something on the books. So so we just now got permission to have visitors. So the next step for the go ahead, Chip, or no. The next step for 73002 core is actually not this. It's to finish the hyperspectral work. So Juliana and I are planning to do the same type of hyperspectral work for Paul inside the core processing cabinet probably next week using the same conditions, although we haven't talked to Paul about that yet. So if he's on the call and he wants to change something, now's the time to speak up. We also need to schedule with Paul. The next step after that will be to move the core from the core processing cabinet into one of our experimental lab cabinets where it can still be inside of a nitrogen atmosphere, but Paul can put the hyperspectral measurement device inside the cabinet around the core and make direct measurements on the surface without the glass in between. Normally we would be worried about contamination, but since the step after that is to embed the entire thing in epoxy, I'm not too worried about the level of contamination from that. So we're going to talk to Paul and hopefully find a time in July where he can come for a visit and do that type of work, because I think that is probably a step beyond what Juliana and I are able to do. Petrographers doing hyperspectral analyses is not a great thing. So after the hyperspectral work gets done, it's time to make it into a thin section. So we have an apparatus that has been around since the 1970s. Here you can see some pictures of what it looked like when we pulled it out of mothballs about a year ago. And obviously it needed to be retrofitted. I think we called it refreshed initially, and then we were calling it retrofitted, and now I think we're just going with rebuilt, because almost everything had to be scrapped and started over from scratch. And so, but we're done. We're at the point where we have our nice fancy new vacuum pump, which isn't that fancy, but it's considerably smaller than the old version. They've refurbished the vacuum chamber. We still need to use clamps to hold the top down, but that's fine. And they have been able to reliably get a 2 torr atmosphere for pulling the epoxy, pulling vacuum on the chamber in order to get the epoxy into the center of the 4 centimeter core. They rebuilt the device. So Jeremy Kent and our electromechanical technicians, and now we pulled Jimmy, who used to be our facility manager. Before that, he made sections for us, and he's the only person alive who's actually done this process before. Jimmy's come back, and he's helping Jeremy as well. And so they've got brand new saw, a brand new incubator. Everything's new or completely refurbished. They've done a safety plan, which is a thing here at NASA. The problem with this is the epoxy, you can't use any hardener. And in fact, you have to use ether as part of the process. So using ether in the lab is the Brad's face just shut it all. That was more or less the face that environmental health and safety here at NASA made. But eventually we explained to them why this had to happen, and they worked closely with us to come up with a safe way to do it. And so we're actually just waiting on them to show up next week to mix the first set of epoxy so that they can see that no one passes out. And then they're ready to do the first test core. And so we're going to take some JSC 1A. We'll probably throw a couple big rock fragments in just for good measure, and they're going to embed it in epoxy and see how it goes. It's a little more complicated than that, and they've spent a lot of time reviewing the old procedures. It is a 3 to 4 week process to do the test. That's the cure time on the epoxy. So the sooner we can get this started, the better. So we're really trying to get it started before the 4th of July. At least 1 test needs to be run, and probably 2. There are a few other questions that have come up, one of which is how to cut it. Now, obviously, we have the saw, and we have a standard procedure for cutting these core tubes, or sorry, these vacuum impregnated core epoxy cores, but it uses ALMAG, it uses oil. That's the standard, that's how every other one was done. And so we'll have the test cores, and so we will test cutting with ethanol, 190 or 200 proof ethanol, which is how we cut off our normal thin section epoxy butts. It's not clear that a 4 centimeter wide by 20 centimeter long core full of rock and epoxy can be reliably cut using just ethanol as a fluid. So if we run into problems with that, we'll have time and we'll come back to this group here and we will talk about what using ALMAG versus using ethanol would mean for the science that needs to be done. All right. Hopefully Brad has better slides later, but moving on from 73002 to 73001, the gas manifold was completed, and Alex and Olga put it in their Subaru Outback, which is apparently the car of choice for transporting ultra-high vacuum apparatus 800 miles across the country. And I say that because Alex and Olga mounted it in their car using plywood and stuff, and we wheeled it into the lab on the highly technical cart you see there. We plugged it in, we turned it on, and it worked. There was a single cracked seal anywhere on it. We didn't have to replace any gaskets. I say we very liberally here. Alex and Olga didn't have to replace any gaskets, and it is currently still sitting in the lab. This is from a couple days ago, pumping at a low 10 to the minus 9 vacuum. And it is sitting there with just the ion pump pumping on it, where it will stay until it's ready to go, or ready to be used. It won't have to be moved to be used. It's It's there, it's right. I've greatly simplified the process, but it all worked out great. I know that ANGSA has made big strides, and I think we'll hear more about that later on the piercing device, and they have a sort of a formal, not sort of, a formal document waiting for approval, and so we'll have a review process of that next week and be able to get them some feedback, and so making progress on that as well. Continuing on about 73001, after the gas is extracted, the next step will be to CT scan it. On the 7300 core, there was no outer CVSC. There was no outer stain. Had the aluminum tube. Not only that, because it was an upper tube, it didn't have a stainless steel bit in the bottom. It was just a solid aluminum tube. And so the question is, how well can we CT scan through both the stainless steel CVSC and the aluminum drive tube that's inside? And so we took one of our flight spares, actually one of our Apollo 17 flown devices, and this is the actual Apollo 17 lower drive tube with JSC-1A and a couple random rock fragments in it, scanned on the scanner here at JSC. This is actually multiple scans that have been pieced together. You can see some of the artifacts. So the bright that you're seeing on the outside of this scan is the steel bit that's in the tube. Now, initially, our question was, can we scan through both the CVSC and the aluminum tube? And the answer is yes. This is scanned through an SESC, which is the same gauge and type of stainless steel with the aluminum tube inside. It's not a perfect match because the SESC has a much greater diameter. And so there's a lot more of an air gap between the stainless steel outer SESC and the aluminum tube. I don't think that matters, but eventually we'll have to get a stainless steel tube that that more snugly fits around the core. Regardless of whether we take it out of the CVSC, whether we do the CT scan before the gas extraction in the CVSC or after the gas extraction, after it's been removed from the CVSC, we are going to have artifacts from the stainless steel bit that's in the tube. You can see the streaks that it's putting across there. There just isn't any way to avoid that. I think we still get pretty good data for the samples inside the tube. And then this is just another view of a couple different energy scans that Scott had run. And so Scott Eckley, who runs the CT lab, has spent a lot of time over the last week or two sort of fine-tuning the conditions that this needs to be scanned under. And you can see we get pretty good data. It's not packed as well as a lunar core. JSC-1A isn't a perfect analog, but it'll be fine.
Ryan, will this be done at JSC?
Oh, the only other thing I have, and I'll blast again, is cold. Lots of good work has been done on the cold. What you can see here is the actual cold processing cabinet being, after it's been bubble wrapped to death, wheeled outside and into the gun lab and lifted with the crane and put into the freezer itself. So right now we have a plumbed stainless steel glove box inside the -20 walk-in freezer. The freezer has had its fire detection system fully installed and programmed, and so we are now compliant to environmental health and safety, and so they are ready for us to continue to work. We have it plumbed for both house nitrogen, and we can use K-bottle nitrogen if we want. And I just got a message from Francis. I can't hear anything if people are trying to talk to me. So, my volume off or something? Well, anyway, this is my last slide, and then I'll stop sharing. The next step is the change room, the clean change room that will be put around the outside of the door, so that we have a way to get into the freezer. Has been installed, or is here. It's ready to be installed next week. Once that is assembled, we'll clean the cabinet. Clean the freezer. They will do some testing, and then we'll make it cold, and we'll do a little more testing. And so we don't have a definitive schedule yet, but everything at this point we control the schedule of, and we're making really good progress. So I'm going to stop sharing and hopefully people can hear me. Or I can hear people.
Great, thank you very much. This is a great update. I'm sure there are a lot of questions for Ryan.
And I can hear now, so
Okay.
apparently I muted you.
I have a question, Ryan. The big A class, it
Yep.
looked pretty coherent in your scan. Was it somewhat friable, or was it in fact a pretty coherent regolith breccia?
Juliana?
It was really coherent. And it was really heavy too. So first we were like, oh, maybe it's something different. But from the full core scan that we had, we sort of knew what it was. And so you can see the Schlieren in there with the impact melt. It's very, very dense and cohesive. So it was not crumbly at all, if that was what you were asking for.
Yeah, right. No, that's very interesting.
Mm-hmm.
Thank you, Juliana, for making a lot of those slides for me.
Other questions?
Yeah. The only thing I'll add is that from a big picture, JSC has gone to stage 2 from stage 3, which is probably linked to being able to have more visitors now. Don't know when we're going to go further down to stage 1, but at least with stage 2, we have a lot more flexibility in what we can do on site, although it's still considered maximum telework.
Ryan, so the timetable for the continuous thin sections is probably early fall? Is that?
Yeah, I think early fall. I mean, it's a 3-week, and really we ought to say 1 month per test. We need to run at least 1 test. That puts us to the end of July. And so even if we start that after that, it'll take all of August for it to cure. Once it's cured, it isn't that many sections. It's only an 18.5 centimeter core. So we're only talking 6 or 8 rectangular sections along the length of the core. And then we can make some 1-inch rounds across the core as well. So, but those will take a few days to a week to make, as opposed to getting cured.
There are a number of people who are waiting to take a look at the rectangular thin sections. Do you know if there's enough material to make 2 or 3 sets that can
Yes.
go around to different teams?
Yep. 100%. So, I mean, the core is, even now that we're, 3/4 of the way down through it, the core is still a good 2.5 centimeters wide. I mean, we will be able to get 3 or 4 serial slices off it and still have material left over. Also, the first step in the process after it's been vacuum impregnated is to cut it in half lengthwise, and we only work with 1/2 of the core. So previous cores have had 2 or 3 sections made, and then still have quite a bit of material left in the potted butt that's being worked on, plus an entire other potted butt that hasn't been touched at all. And so we'll be able to make more or less as many sections as people need within reason.
Great. With regards to the lithic fragments, are you going to make thin sections of those upon request, or are you just going to make thin sections of all of them anyways?
Upon request. I'm not planning for us to make sections of anything that people don't ask for, mostly because we have the CT scans that allow us to do the same level of recon that we might otherwise. Now, you can't do the same type of work, but I'm counting on people using the CT scans to identify which class they want to work on, and we will make sections for the more detailed analytical work based on requests using that. Whereas before, we would have to make sections in order for people to get an idea of what the class is to then request it. I think we've skipped that step. So in the past, we would have made sections, representative sections for most of these class, and I'm not planning on us doing that this time.
Chip, I think Brad needed to ask a question.
Yes. Any other questions?
Yeah, hey, Ryan, I have one more question. And I might have missed it. You said something about this, the past 3 unsorted samples and people and somebody doing coming down to hand pick those?
No, sorry. Well, I think I didn't mean to say that. What I meant to say is that I know Darby and her group are waiting on glass beads. They don't need to come from pass 3, and in fact, they probably should come from pass 1 or 2, since it'll have the larger material separated out. So I'm saying if and when people are ready to come down, we can do that. And if we have someone come down and hand pick through material, we won't have them hand pick through the entire interval. We will take a subset of the interval, half a gram or a couple hundred milligrams, separate out that, and then have them pick through that. That way we don't bias the entire interval for whatever phase is being picked out.
Yeah, okay, that's good. I understand now. I just wanted to make sure, you know, we're hoping to get unsorted sample materials for noble gas analyses. And I didn't think we were going to come and hand pick those. I thought those would go ahead and be selected for us.
We can do that for you.
Okay.
Brian, the grad student would come tomorrow if.
Okay.
You know, you tell me when we know who it is if there's security stuff. So you call the shots as soon as you're ready. She's on an airplane.
All right. Well, then we will. I don't think we can do it before the 4th of July, but we can set it up for early July, I think. Let me talk to Andrea and Juliana and find an exact day or two, and we will get everything set up.
Sweet. All right. I'll pass the word on. That's awesome.
Is there anybody from the Hawaii group online right now?
I see a comment from Hope.
Okay.
Hi, yeah, I'm here. I think Rich Walroth's on as well. I don't see Paul Lucy. I wasn't sure which line of inquiry you're going into.
Well, what I wanted to do is just see when Paul had time to come to JSC to do the last set of imaging, multispectral imaging on the core prior to it being made into continuous thin sections.
I can send him a text.
Yeah, I think he was going to be surprised when I said that, because I hadn't had a chance to email him yet. I knew that we weren't going to be able to make the continuous thin sections till August, but we do need to find a time for him to come out.
Okay, I'll send him a quick text and then he'll have had the heads up.
Ryan,
Alex,
do you want to
you have a
email
question.
him or you want me to? Ryan,
I'm sorry, say that again, Chip?
do you want to email Paul to remind him, or would you like me to?
I will email Paul and remind him, and I'll copy you on it just so you know what's happening.
Okay, great.
And Alex, I think Alex Elke has a question. I can't hear you if you're talking, Alex. Still can't hear you.
There you go. Sorry.
There you go.
Okay. Quick question. I need something from my branch management to lead me back into the lab. I'm still working on this. Can you give me, like, I know you didn't say a specific date for the cold samples, but if you would estimate, like, what do you think when you can set them out? Is it August? Is it September? Just something on that scale.
I hope it's not September. Once we get the change room installed, that's the last thing that we have to bring people in from outside to do, which it is scheduled for next week. Once that happens, it becomes largely an internal process where it's us cleaning it, it's us doing the testing, and I can make a more concrete schedule once I no longer have to wait on other people that I don't have complete control over. So I can just say August. Or I can just say, I mean, I'm not going to lie to them, but I mean, we would like to get this done and the samples out by August.
Sure.
You know.
Yeah, that's just something I need to tell my branch to I need to put pressure on them to let me in. They understand it's their
So
problem.
if you want to email me, either copying them or not, and I can just write them an email, or if I need to write something more official, I can do that as well. But if you want to write to me and ask for an update, I can reply to you and give you the update.
That's fine. That's great. Thanks.
Sure.
Any other questions for Ryan? Because I do have one more. Okay, Ryan, now that we've dissected core 73002 and we're looking forward to dissecting 73001, are there any lessons learned from the dissection that could change our thinking in terms of strategy for 73001? Like, for example, after we do the de-rind and send out some material for labs that we want, do we, for example, don't want to sieve past one, and that way get those materials quickly to the organics people and to the rare gas people, and then essentially sieve past two? I mean, that seems like, because you're not sieving, it would let us get through the core quicker. And that's just an example in terms of thinking of strategies and dissections.
I mean, I don't think we would do that. I don't think we would not sieve past one. For past one, we did not sieve of the intervals that went to the organics folks, as an example. So we can mix and match. If there are specific allocations that require from past one, part of it to not be sieved, this is our process. We can do it how we want. But most people want sieved material based on the number of allocations we gave from 1 and 2 versus past 3. And so I think waiting longer, waiting till past 2 to sieve it will actually end up making people wait longer. I think what we might do is more people should get material from past 1 next time as opposed to past 2, even though it is a little farther from the center. I'm not sure there's a real difference in the quality of material after the de-rind between past 1 and 2 in terms of chemical purity. Past 3 is different because it doesn't get sieved, but there are a few things like that. I think we learned some things about the science team coming and helping, and that if we can get folks to come for longer chunks of time so that we're not reteaching folks on a weekly basis, that's helpful. That there's less of a learning curve and more of a, it becomes more of a sustained production, things like that. But certainly if people have concerns or comments or questions, just let us know, and we will find ways to work them into the process as long as it doesn't put the overall health of the sample at risk.
Good.
That anyone here would ask for that, but.
Okay, great. Any other questions for Ryan before we move on?
Sorry, I know that took a long time.
Although that's okay. You had a lot of goodies. All right, then. Let's go ahead and move on to the next item on our agenda, and that is with regards to ANGSA data management plan. And this is different than the PE data that will be kept and documented at JSC for future allocations. But this is the data that all of you put into a data management plan into your proposals. But we were requested, I think recently, last week, I think, to perhaps have a ANGSA team effort in data management plan. And Francis, do you want to discuss this just a little bit?
Yeah, I can discuss it. For some reason, they took away my ability to show video, so I'll just talk without video.
Francis, hold on. I have to make you a co-host. Are you Francis McCubbin?
McCubbin, yeah.
Oh, you're definitely McCubbin from now on.
Enough out of you.
You should be able to share now.
Great, thank you. So one of the overarching directions that NASA seems to be moving for archiving sample data is to put it into what's called AstroMatDB. I believe that's the name now. This is what started out as MoonDB, and it's now being extended to all astromaterials. And we've been asked as a team, as an ANGSA team, to make sure that we have a place to put our data, and I believe the preferred place would be AstroMatDB. I don't think this is going to be too onerous or create any problems. And Ryan, who's done a lot of work with the folks at Columbia who set this up, has volunteered to be the point person on the ANGSA team to kind of act as a liaison between putting the Columbia folks in contact with the members on the team to make sure that our data are getting appropriately archived. Ryan, I don't know if you want to add any additional words, but I think this should be a pretty easy thing for us to do.
Yeah, it shouldn't be too bad. And now I'm glad I made fun of your name since you volunteered me for this. I mean, I volunteered for this. It's a straightforward process to submit data to AstroMatDB, and they have spreadsheets and templates for different types of data. So it's really just a matter of having the individual PIs talk to them, get the right data format, and just submit their data. They're very responsive.
And this isn't going to be, in lieu of putting things in supplements like we normally would. But headquarters is definitely moving towards a more comprehensive system where all data produced by NASA funds become publicly available in a data archive. There were a lot of discussions that, we used a PDS node for doing this kind of thing. And I think everyone sort of agreed that that wouldn't really be the best format for archiving sample data. And so we're really moving towards this AstroMatDB to be the catch-all for planetary sample data. I think that's all I have to say about that, if there are any questions.
And also, Francis, this is actually probably a good dry run for Artemis and Artemis samples and sample analyses.
Yeah, definitely. I mean, this is a requirement that is going to be broadly applied. And I think we've seen that evolution with the data management plan requirement within Rose's proposals. And I think, things are going to get more formalized as we go, particularly as AstroMatDB matures.
Francis, is there any accommodation for image data?
Yeah. Any kind of data that we'd normally collect on samples, images, even X-ray images and things like that, spectra, all of that they have ways to archive all of that data. And they also are interested in having all of the metadata that goes with it. But Ryan's role as the liaison is to kind of help us understand what formats and what kinds of information and what kind of metadata they will need to put it in. And so we'll make sure that everyone has what they need to do this properly.
Any other questions for Francis or Ryan?
The only thing I'll add is that while they have the ability to ingest images, and the original pilot program was taking John Delano's BSE or his optical images of glass bead analyses and then tying the individual analyses to where they were on the section. Individual, a few X-ray maps or backscatter images is one thing. If you have data intensive gigabytes of CT data, as an example, that's not something that's being planned to be hosted in the AstroMatDB. So that will be and is being hosted in the PDS. And so, I know Francis knew that, but just in case, Brad, that's what Brad meant. Individual images that go with analyses, great. Hundreds of analysis and hundreds of large format images, no, not so much.
Ryan, will that be the geosciences node or the imaging node?
Yeah, that's a great question. Right now it's both. Some go to one and some go to the other, and that's not great. So we are just going to have to figure out which one we want to use and use it. If you know anybody, sorry, Ray's not listening, right?
I'll go upstairs and talk to somebody.
Any other questions for Ryan or Francis? Okay, let's go on to the next agenda item. And this is with regards to the lessons learned document that I sent to many of the people on the UNM team and also to the PIs of the other sub-teams and to curation. And I received and made modifications to this document. I sent this version to you, which again, across it, it says draft. And then it went to Sarah as she was the NASA official who requested this document. What she would like is to meet with people from curation, and that's with regards to people tied to ANGSA, but she also mentioned Julie Mitchell as another person she would like to meet with. And then, of course, anybody or most people who are interested from the ANGSA team. And again, I can't open this up to everybody on the ANGSA team. So I would appreciate if you were interested, just to send me an email. And so I can put together a small group of people who can interact with Sarah on the lessons learned document. She would like to meet with this group on July 8th at 3 p.m. East Coast time. So please go ahead and email me if you're interested. And I will put you on our list of people who will meet with Sarah about this document. Again, this is a document that outlines year 1 and 2 of ANGSA, and we will be putting together another document that's year 3 and 4. Any questions at all? Great. Well, again, please email me if you are interested. And Ryan, could you go ahead and send somebody to represent you? And again, other people from curation hopefully can make that time. If not, again, please let me know, and I may have to adjust that with Sarah.
Okay, we'll talk about it internally.
Okay, okay. Let's see, so that does that. The next issue I wanted to bring up was the status of the Apollo 17 ANGSA workshop. I'm just starting to put together a document for that workshop. My intent is to have that run in the second half of 2022. So the second half of August 2022, that it's the date that we still need to determine. We're still working on the potential site where this meeting will take place. I've had discussions with several of you concerning possible locations. At least for me, I would prefer we select a site that is easiest for me. Not in terms of easy for me to attend, but easiest for me and the LPI to organize. Once we have a draft of the announcement, I will send it to the whole ANGSA team. Now remember, the goal that this workshop is a joint Apollo 17 ANGSA workshop. And so there will hopefully be numerous individuals who have new sites tied to the Apollo 17 site beyond ANGSA. And again, remember, this is partially also a celebration of the 50th anniversary of Apollo 17. Now, we will have part of our publication strategy is tied to this meeting, and we will discuss that in a few minutes. Finally, I do have a organizing team or our organizing group together already. If you have some interest in being a member of the organization team, again, please let me know. I really want to have a mix of, again, ANGSA and non-ANGSA people. I anticipate that the workshop will be 3 days, and either prior to or after that workshop, I would like to have an ANGSA team meeting. Again, contact me with questions, or if you're volunteering to serve as a member of the organizing committee. Any questions with regards to that? And again, as I mentioned, it's really in the initial stages of piecing this together, but I would like to have this out as an announcement the summer of this year, the latest in August. And one person requested that Brad Jolliffe serve as the member of the program committee or organizing committee, but that's something Brad and I can talk about offline.
Hey, Chip, speaking of, one thing I would ask is if we're looking at August timeframe, that we try to schedule it before the universities start their fall semesters.
Okay, all right. I'll try to do that as best as I am able to within the potential time frame and requirements of the LPI. Let's go now to the Apollo 17 special session. Obviously, next year at LPSC will be a celebration of the 50th anniversary of the Apollo 17 mission. And we will not have, I will not request a special ANGSA session. Hopefully, and it won't be me, others out there will request a Apollo 17 special session. And those requests, I think, are due near the end of this year. I think last year, I think they were in the October, November timeframe. So if you're interested in submitting a request for the Apollo 17 special session, please get organized and send a request. And I'll monitor that. And I really do foresee that ANGSA will have numerous talks in that session. Any questions with regards to that, or people who are interested in volunteering to do that? All right, let's move
Hey, Chip,
on.
Noah here. I'll take a stab at a special session if and when the opportunity arises. I'm happy to help coordinate that.
Okay, that's wonderful, Noah. And again, this is a celebration of Apollo 17, and hopefully we'll be able to include some ANGSA talks in the special session.
Absolutely.
Okay.
Hey, Noah, this is Jack. If I can help you on that, let me know.
Oh, I already have a role for you, Jack, but I'll need your help for sure. Appreciate that.
Now, over the last few weeks, partially tied to this workshop, but also tied to illustrating some productivity with regards to ANGSA, Francis and I came up with a straw man schedule or strategy for publications, ANGSA publications. And Francis, I think you and I agreed to this, but do you want to go ahead and go through our initial strategy?
Yeah, and again, this is just an initial strategy. It will have to be modified based on results that we end up getting as we analyze samples. But sort of the first thing we were thinking is either a single paper or several papers that kind of outline an overview, ANGSA, what it is, why now. For something like space science reviews that kind of like, you know, you see when missions come out, they have a lot of setting up what the whole thing is going to be about and the goals, and also some of the, you know, technological hurdles that needed to be overcome in order to make it happen. And so that could be the first thing that we try to bring together. And like I said, that could be one kind of overview paper, or if there are certain parts that need to be, you know, highlighted separately, that is another option. Once we have the results and we kind of know what our highest profile results would be, we may try to approach a higher profile journal for a series of papers. Again, this is pending the results, but it also sort of mirrors what a mission would do. And then after that, we have kind of the longer follow-up papers in, you know, 1 or 2 special issue journals tied to all the results from ANGSA. And again, this is the straw man. It's going to be flexible and certainly change as we know what our results are, but that's kind of the broad concept. And also happy to hear feedback or take any questions. This was sort of just something Chip and I were discussing.
And also, in terms of this broader set of papers, it would be kind of nice, at least the first set of papers, that we do link it to the Apollo 17 ANGSA workshop with authors and co-authors either bringing electronic version or hard copy of their paper actually to that meeting. You know, I would really hate to have this to announce at the time of the meeting that we're going to have a special issue and have that drag on for 1 or 2 years. I would like to try to do this special group of papers associated with the meeting done fairly quickly. But again, this is something that Francis and I just discussed over the last couple weeks. And, you know, we really are open for comments, and some of the timeline for this will really be dependent on the results of our analyses and how much we've progressed on these analyses. Do I have questions out there?
Hey, Chip, this is Jack again. You know, back in the early days of the Lunar Science Conference, Lunar Planetary Science Conference, etc., the volume of proceedings was put out within a year.
Mm-hmm.
And if there's somebody around that remembers how that all was done, it might be useful to talk to them. Because, you know, the ANGSA Apollo 17 activity, if it goes as you and I would like it to, would be, I think, red meat for some major papers that would be nice to have in volumes, such as we used to have for these LPSC conferences.
Okay. You know, again, I don't think I'm not old enough to be involved in many aspects of that. But let me explore with some of my elders to find out how that was done.
Yeah, you know, Grant Hyken might recall. He's one person.
Okay.
But it was a long time ago, but it was amazing, always amazing to me, still is since I use them so much, how rapidly they were able to get these papers bound up and published. And they're really, it's a great resource. And if the workshop goes as we would like it to, it would sort of, augment that resource in some major ways.
Okay. Brad or Steve Simon, were you involved in any of these publications, in the mid 80s?
Not in the production, but I submitted papers to them. And for the proceedings, there were deadlines after the meeting, I think a month or so, and they were reviewed very promptly in about a month. And then you had to submit the revised paper in about a month.
Okay.
And then
All
the
right.
bound volumes came out about the end of the year.
All right. Yeah, I think that's kind of the time frame that I wanted to find out how they essentially did that. All right, Steve, thank you.
I can look at my papers, and some of them say when they were submitted, when they were received. They got turned around very quickly by reviewers. I remember that. And we
All
can
right.
look at those volumes, see who the special editors were, and see who's still around.
Okay. Great. Brad, did you have anything to add?
Well, no, I think what you just said was key. Having special editors who are dedicated to making sure to shepherd the papers through the review process is pretty key.
Okay.
Having a dedicated group of reviewers who know that they have to have a fast turnaround.
All right. Okay.
Yeah, and a lot of the journals, I know GCA and MAPS both kind of bring on special editors for these special issues to do just that.
Okay. All right.
And it was all done with hard copy. I don't know if you want to go back to that, though, in the US mail.
All right. And finally, what I'd like to do is get an update from a number of individuals tied to the gas extraction in terms of the tools, and also in terms of, a potential schedule we could be on. And why don't we just go ahead and start with Alex and Brad with regards to the gas manifold. I know what the status is, but I'm not sure everybody on the team thus far knows.
Yeah, I'd say Alex, why don't you go ahead and maybe you might summarize who was at JSC when you delivered the system. So you met with Chip, and I think you met with Zach also, right?
So it was already said that the manifold and pumping station and water flow master parameters are all installed and waiting for the punching tool. We have a short discussion about how much we can extract from these gases. And we discussed the possibility that we can a little bit, after first extraction, we can a little bit heat the core and maybe have another extraction. But it didn't work because of the organic people, and so we don't want to heat the core. We decided to do differently. The diffusion of gases depend on temperature, of course, and also on time. From temperature, it depends exponentially. From time, it depends on the square root of T. So we decided to preliminarily to make the second extraction isothermically. So after we make the first extraction, we maybe wait another 10 days, and maybe some gases from inside the core, because the surface is huge, will go to the surface and go to the gas phase, and we collect this extraction also. And this is now, we start working on that. And I think Chip knows more than I do.
What's the status of the 4 extra sample tanks?
The 4 extra sample tanks were ordered. And so again, I think You both mentioned that it would take 2 months or so or to be delivered. I think that's what you mentioned, Alex, right?
Yeah, yeah. That was also written on the quote.
Yes, yes. And they will also send me plans for these extra containers, which they haven't done yet. And they will send it to us all in one piece or all together, and not drips and drabs like you suggested would not be the way to go.
Yeah.
Also a modification in terms of gas extraction. I think during our meeting in May, we decided also to extract the gas that is in the container surrounding the core sample vacuum container, that we were going to do that also. So there will be actually numerous rounds of gas extraction without, again, modifying the sample itself. And so the sample will remain fairly pristine, and we are essentially not doing any damage to it at all.
Hey, Alex and Chip, Brad, have you looked at what the consequences of some acoustic stimulation of gas release might be?
You know, we didn't talk about that very much, and we really need to a little bit more, Jack. Again, the concern was, as you know, whether anything along those lines would disrupt the stratigraphy.
Yeah, exactly. But I think there might be a way to test it. But you know, if some whether it's low frequency or high frequency, I don't know. But the stratigraphy should be fairly compact in that core, as a matter of fact.
Well, you know, actually looking at the upper part of the core, you know, the upper part of the core wasn't really that compact. And so that was, again, my concern. But again, that's, yeah. I'm going to be going down to the Johnson Space Center again next week, and this will be something we can talk about perhaps a little bit more.
Yeah, I don't know whether there are any precedents out there that would help, but boy, it'd be nice to get a good full sample of those volatiles, no question about it.
Okay. Let's see, is Fran online?
Hey, Chip, before we move on to that, there's a question.
Go ahead, Francis.
Yep, sorry, before we move on to that, there's a question in the chat about whether a decision has been made about warming the container to extract gas. And I think the decision is that we're not going to do that because it poses too much of a risk to the sample for other studies and future studies.
Yeah, yeah, and Alex did mention that.
Yes, that's what we decided.
Yep. Okay. Fran, will you go ahead, please?
Hey, Chip. Yeah, just to tag in about the gas extraction piercing tool, the can opener, as we like to call it here. So this will interface the CSVC with the gas extraction manifold that Alex and the team have been building. So we've got a consolidated design now that had an intermediate design process we went through. It was shared with JSC and the Gas Extraction Committee, and we had feedback then. That feedback's been incorporated, and then we had a breadboarding session at the European Astronaut Centre in Germany, where the core team leading the design work are based, and there was extra modifications, just minor tweaks made to just ensure that we're getting tolerances correct, because we're aware of the importance of meeting science requirements, curation requirements, but also the need to meet ultra high vacuum conditions. And then you've got some quite complicated mechanisms working there as well. So we're also particularly aware that once the piercing has happened, it is then only sort of the chamber housing of this tool that is protecting the sample from atmosphere. So it's been taken really seriously. I know there's concerns about this thing being over-engineered, and potentially that could be happening a little bit, but I think it's worth the stringent procedures we've gone through to just really take seriously the fact that the housing is what stands between exposure to atmosphere and not once it's taken out of the glove box and has been pierced. So this is what we've really worked towards. So understand you're going to go through the design, and we'll have a follow-up on this perhaps in the next week or so. There was a few kind of outstanding questions that were there, again, that need just a little bit of input. Because we've been trying to really stick to the strict material requirements of JSC regarding it being in the really stringent clean glove box. It's just we're finding a little bit of difficulty to be able to sort of work to vacuum seals and valves. You need some form of lubrication. Now I can understand you don't want nasty oils or anything in there. So it's just what are the alternative dry lubricants that we can maybe use? So there's things like silver coatings or different like bronze alloys, and I suspect some of these may also be a little bit questionable. So we just need to discuss what are the alternative approaches that we can go to make sure that we're meeting the sealing requirements, but without risking introducing any contamination that could affect the remaining solid sample or people's science analysis. So those questions are there. I hope to discuss some of these questions both with JSC and then a next gas extraction committee. But beyond that, I think we're nearly there. And if we can go ahead with a build as soon as possible around July timeframe, bearing in mind there's people have saved up a lot of holiday now that they're finally hopefully going to be able to be freed and go on holiday. There's sort of some time constraints there, but at the moment we're working towards trying to fit towards a kind of September delivery timeframe, which I think was discussed before. But it's just a case of getting the feedback from everyone and the go ahead on the design and addressing some of those questions.
Yeah, Fran, I think what our plan is, and not everybody knows this, but again, I'm going to be at the Johnson Space Center next week. We thought, because most people at JSC are free on Tuesday afternoon, that we would discuss the design and the plan on Tuesday afternoon among Francis, Ryan, Uliana, and myself. And then after that, Alex, I'm not sure what your schedule is for next week, but would it be possible for you and Fran and Alex, anybody else who you think should be online, to then have a teleconference either Wednesday or Thursday? Does that at all fit into your schedule?
Yes, absolutely.
Okay. Let me just go ahead. I'm sorry.
Yeah, of course.
Okay. Let me go ahead and check with the JSC people to see their availability on Wednesday, and then I will try to set something up.
That sounds perfect, and then it will give Ryan and Francis a break from receiving poking emails from me as well. Okay. I just had another question. It's great to hear about the CT scanning looking through the double layers, because part of what the design involved was there's a little bit of uncertainty in the design as to what the distance is between where the drive tube sits in relation to the base of the CSVC. So the design has had to be extracted in working on what is being calculated as a maximum and minimum distance, being aware that we want to pierce the CSVC, but not the Teflon cap of the drive tube. So actually having that information in those images is not only great, obviously, for the science, but would be really useful for helping to calibrate the mechanism to really make sure we're not piercing that Teflon cap.
Okay. Any other questions for anybody else on the gas extraction subcommittee? I know we're running a little bit late, But I just want to open this up to anybody else who had want to discuss an issue or if they had any questions. Great. While we go ahead and end our meeting, I just want to thank everyone who's attended. It looks like we're making real progress on getting everybody the samples that they need, either now or shortly. And we do have a really nice plan slowly coming together for both publications, for meetings, and for processing the next round of the next types of samples that I think many of us are extremely interested in. And again, if anybody, go ahead, I'm sorry.
This is Jack. I was just going back to the publication. You know, I don't know whether any of you worked with Rob Godwin up in Canada or not. He doesn't publish hardcover volumes, but he is very active publishing a variety of space-related stuff. So you might make it a little note that if we're looking for somebody who can actually do the legwork of publishing, not of editing, but of publishing, Rob might be a person that we could talk to.
Okay, Jack, would you send me his name just in the email?
Yeah, and I'll give you his email address so you can.
Okay.
You'll have it. Yeah, I'll do that.
Okay. Well, again, thank you all very much. And several of you I will be seeing next week.
Hey, Chip,
Yes.
could I ask Dick Morris and Mason Newman to stay on for just a minute after the call finishes?
Sure.
Okay, thanks.
Take care, everyone.
Yeah, thanks, everybody.
Stop the recording.
You can stop, Ingrid, you can stop the recording right now.
Okay.
And we're just going to stay online for a short amount of time just to talk a little bit